You know those big questions in physics that kind of make you rethink everything? We're diving into one of those today.
Oh, yeah.
It's this new model that basically says the whole universe is like a giant wave machine.
A wave machine. So everything we see, everything we are, it all comes down to waves.
That's the idea. Not just light waves or sound waves, but waves that make up gravity, matter, even space and time. Wild, right?
It's definitely intriguing. I mean, we know waves exist, but to say the universe is built from them, that's a big claim.
It is. So are we ditching particles as the building blocks then?
That's what this model proposes.
Yeah.
Think of it like this. You drop two pebbles in a pond, right?
Okay.
The ripples spread out and they run into each other. Some get bigger, some disappear. That's constructive and destructive interference.
Right. And this is happening on a cosmic scale.
Exactly. It's just with waves we can't see or even fully comprehend yet.
Okay, so maybe we can ease into this. What about the Big Bang? Does this model change that whole idea too?
It does. In this model, the Big Bang isn't an explosion from a single point. It's more like this insanely intense moment of all these waves interacting, like a super dense wave soup, I guess you could say.
So not things flying outward, but waves suddenly unfolding everywhere at once.
Yeah, kind of. It's about going from a highly ordered state of these wave interactions to the expanding complex universe we see today.
That is mind-bending. But what about the expansion itself? I mean, things are still moving apart, right?
Well, yeah, but in this wave-based universe, the expansion isn't about things moving through space. It's more that new space is being created by the waves themselves as they interact, like weaving a tapestry, but the tapestry keeps getting bigger.
So the universe isn't expanding into something. It's creating space as it goes, all thanks to these waves.
You got it. And this actually ties into another thing. You've always been fascinated by quantum entanglement.
Oh, right, that spooky action at a distance thing?
Exactly. This model could explain how particles can be connected across vast distances. Imagine a giant web made of waves, and each particle is like a little knot in that web. You tug on one knot.
And the whole web feels it.
Exactly. That ripple effect could be what's behind entangled particles.
So we really are all connected then, not just in a metaphorical sense, but through this underlying network of waves. I like that. But does this model work for the big mysteries, like dark matter and dark energy?
It's actually where this model gets even more interesting. Let's take dark matter. We know it affects gravity, but we can't see it. In this model, dark matter might not be particles at all. It could be concentrated wave energy.
Wait, so instead of invisible particles, we've got phantom waves messing with gravity.
Kind of. Think of these waves warping space-time, creating areas with stronger gravity. It would look and act like dark matter, but without needing those mysterious particles.
So gravity itself could be a result of these wave interactions. And dark matter is just a side effect of really intense wave activity.
Right. And it gets even wilder when you consider dark energy, the thing driving the universe's expansion faster and faster.
Yeah.
This model says dark energy isn't some separate force. It's just the natural tendency of waves to spread out. Remember that expanding tapestry analogy? It's like the universe is constantly surfing its own wave.
Okay, so dark energy is built in. It's not pushing the universe apart. It's more like the universe's natural wave motion.
Exactly. It all comes back to that core idea.
Yeah.
The universe is a wave machine.
This is blowing my mind. But what about time? Time moves forward, right?
Yeah.
How does this wave model deal with that?
That's where wave interference really comes into play. You know how when you drop ink in water, it swirls and spreads in a way you can't undo?
Yeah, I see what you mean.
The universe is kind of like that. As waves interact, they create patterns that become more and more complex. That increasing complexity, the fact that you can't go back, that's what we experience as time moving forward.
So time's arrow isn't some mysterious force. It's just the universe's wave patterns getting more complex, like a cosmic record player that only goes forward.
That's one way to think about it.
Okay, so what about black holes? They're already pretty extreme, but in a wave-based universe.
Oh yeah, they get even weirder. Picture waves converging from all directions, all focused on one spot.
Like a cosmic wave mosh pit.
Something like that.
Yeah.
That intense concentration of wave energy warps space-time so much that nothing, not even light, can get out. That's a black hole in this model.
So it's not sucking things in, it's more like a point where the waves are so strong they create a gravitational sinkhole.
Right, and the event horizon, that point of no return, it's not a solid barrier. It's just where the waves are so powerful, nothing can overcome them.
My brain is definitely doing gymnastics trying to picture all this. But what's really cool is how this model connects so many different things. Quantum entanglement, expansion, black holes, all through waves.
It's a pretty elegant framework, isn't it? And it makes you wonder, if everything is waves, what does that mean for us? For reality itself?
That's what I want to know, and that's what we'll dive into next, right?
Hmm.
Because if everything is waves, what does that mean for technology, space travel, maybe even our understanding of consciousness?
All those big questions. Stay tuned because we're just getting started. It really does make you think, doesn't it? If this wave model is right, I mean, what are the implications? Does it change how we see reality itself?
That's what I keep coming back to. We've talked about black holes and the Big Bang being all about waves, but what about us? What could this mean for, like, everyday life?
Well, one area is technology. Quantum computing, for example.
Right. I'm fascinated by that stuff.
Me too. This wave-based model could give us totally new ways to use quantum entanglement.
So instead of trying to control individual particles, we'd be looking at manipulating those waves directly.
Exactly. Imagine being able to tweak the wave patterns that connect entangled particles. That could lead to a whole new type of computing.
Wow. So instead of bits, we'd have wave interference patterns. What could we even do with that?
The possibilities are huge. Think about simulating really complex systems, like for climate modeling or drug development. We could even unlock a deeper understanding of the laws of physics themselves.
Okay, now you're really getting me excited. What about space travel? Could this wave model help us get to the stars faster?
It's worth thinking about for sure. If space-time is really a wave medium, like this model says, maybe we could find ways to manipulate it, create shortcuts, maybe even wormholes, by warping space-time itself.
Whoa, that's some serious sci-fi stuff. But let's bring it back down to Earth for a second. This model says we're made of waves too, so
Yeah.
are we just walking, talking bundles of wave interactions?
In essence, yeah. Our bodies, our thoughts, our experiences, it could all come down to patterns of wave interference. It's a big shift in how we see ourselves.
It is. But if our thoughts are wave patterns, does that mean we could influence them directly? Like, could this explain telepathy or even consciousness itself?
Those are really interesting questions. And while this model doesn't have all the answers, it definitely opens up new avenues to explore. If everything is linked by this network of waves, maybe there are ways to tap into those connections that we haven't even discovered yet.
This is seriously making me question everything I thought I knew. I have to admit, part of me is skeptical, but another part is just blown away by the possibilities.
Yeah.
But how do we even know if this wave model is right? What would it take to prove it?
Well, that's where the real science comes in. This model makes some pretty bold predictions. Like, if dark matter is really just wave interactions, we should be able to map those interactions and explain the gravity we see without needing any new particles.
So we need to create a kind of map of these invisible wave interactions using math and wave equations.
Exactly. And for dark energy, if it's just the natural behavior of waves, we should see little changes in the expansion rate that match up with changes in wave density.
That sounds like we need much more powerful telescopes and experiments to actually measure these wave interactions on a cosmic scale.
It'll be a huge undertaking, for sure. We'll need new kinds of telescopes that can detect those subtle wave patterns in space-time, new experiments that can probe the quantum world even more precisely, and of course, brilliant minds to make sense of it all.
Feels like we're on the edge of a whole new era of scientific discovery.
I think so too. Even if this wave model turns out to be only partially right, it could totally change how we understand the universe and our place in it. It reminds us that there's still so much we don't know.
Okay, one last question. It might sound a bit philosophical, but if the universe is this giant wave machine who built the machine, where did the waves come from in the first place?
Ah, the ultimate mystery. This model doesn't really answer that question directly, but it does offer a different way to think about it. Maybe the universe isn't something that was built. Maybe it's more like a process, an endless dance of waves, constantly creating and recreating themselves.
That's a beautiful image. It's like the
Yeah.
universe is this self-generating symphony, and we're all part of the music.
Exactly. And who knows what other melodies are out there waiting to be discovered.
I love that analogy. It's amazing to think about our place in this vast, interconnected universe. But what about the future? If the universe keeps expanding because of these waves, does that mean it'll go on forever? Or is there a limit?
That's a question that's had cosmologists scratching their heads for ages, you know? And with this wave model, the fate of the universe really depends on how those fundamental waves behave over, like, unimaginably long timescales.
So if they just keep creating more space-time as they spread out,
Yeah.
the universe could just expand forever.
Yeah.
It's hard to even picture a universe without an end.
It is, isn't it? But eternal expansion isn't the only option here. Remember those regions of intense wave convergence, where the waves create black holes?
Yeah, those cosmic wave mosh pits.
Right. Well, imagine if those zones of convergence kept growing, maybe even merging together over billions of years. If those inward pulling waves became strong enough, they could actually start to counteract the expansion.
Wait, so instead of expanding forever, the universe could actually start shrinking, like a balloon deflating.
Exactly. Some theories based on this wave model say that the universe might go through these cycles, expansion and contraction, kind of like a cosmic heartbeat.
A cosmic heartbeat. Wow. But what happens to everything during the shrinking phase? Would it all get squeezed back into a single point?
That's one possibility. But there are others too. Imagine the universe contracting, but instead of collapsing completely, it just hits this like super compressed state, a reset button basically, and then it expands again.
So it would be more like a cosmic spring, squeezing in and then bouncing back out, starting a whole new cycle.
That's a good way to picture it. It's all theoretical, of course, but it shows how dynamic this wave-based model is. It really makes you rethink those linear ideas about time and consider that maybe the universe goes through cycles of creation and destruction.
That's a huge shift in perspective. Makes you realize that nothing's really static, not even the universe itself. It's all about change.
Absolutely. And that brings us back to you, the listener. We know you love these big, mind-blowing questions that make you rethink your place in the cosmos. So here's a final thought to ponder as we wrap up this deep dive. If the universe is fundamentally about these waves, always in motion, always changing, what does that mean for how we understand reality itself?
That's a big question to leave everyone with. Are we just like fleeting patterns within this giant cosmic symphony? Or is there something more, something that lasts beyond the rise and fall of these universal waves?
Those are questions that philosophers and scientists have been wrestling with forever. And maybe this wave model, with its focus on interconnectedness and constant change, can give us some new ways to think about these age-old mysteries. Maybe it can help us see the universe not as this fixed, unchanging thing, but as a process of endless creation.
And the best part is, we're all a part of that process, part of this wave-powered universe.
Yeah.
Constantly evolving, always revealing new wonders. So keep exploring, keep questioning, and keep your minds open to the endless possibilities out there as we continue to unravel the mysteries of the cosmos.
Because as we've seen today, the universe is far more interconnected and dynamic than we ever thought possible. And who knows what incredible discoveries are still waiting to be made.